Hello, and welcome to physics. This is our class on physics, and I'm your teacher, Mr. Anderson. And I just want to welcome you into the class. I think that you're going to enjoy taking this class. The format of the class is different, as I already explained in class. And so this is our first chance to sit down and chat via video. Now, there's a couple of things that I want to talk to you a little bit about when it comes to how do you sit down and watch a video, okay? And the one thing is that these videos are always going to be kind of capped at 15 minutes. So there's no going over 15 minutes. But that doesn't mean that it's going to only take 15 minutes to watch the video. One of the things that you're always going to want to do is make sure that you have your notebook and a writing utensil handy. Because again, this is about kind of note-taking. And the advantage of actually taking a class in this structure is that you're going to be able to pause the video. So you can kind of stop it, you can back up a little bit if you miss something. So if I seem like I'm talking fast, you're in control of that speed, okay? I'm going to be just kind of giving the information and talking through different things and explaining some stuff, but you can always pause it, slow it down, back it up, and there's external sources that you'll be able to kind of go to as well. And we'll kind of talk a little bit about those external sources as well throughout the videos. So now, one of the things we want to focus on is making sure you're prepared to take notes as you're doing this. Now, there are a couple of different things that happen when I do videos in this way. One, I don't get to see your lovely faces, okay? And believe it or not, but as a teacher, when I see your faces, it helps me kind of gauge whether you're getting stuff or whether you're not getting stuff. And that's kind of how I can kind of relate it. So I have that as kind of a disadvantage. And maybe a disadvantage to you is that you're not able to actually stop me and ask a question. Now, there's a couple of ways that we are going to tackle this. First of all, when you come into class after watching a video, the night after watching a video, I'm always going to ask, were there any questions? Now, what you need to do is make sure that when that question popped into your head, write it down, okay? You can put it down on a little Post-it note. You can stick it on your page in your notebook so you have it. You can write it right into your notebook and put a little big bubble around it. But you need to make sure that you ask those questions. If you want, you can just quickly ask me right before class begins, say, hand me your Post-it note and, say, this is a question that I want to have asked, so you don't have to ask in front of the class, but then I can address those things, okay? And so I can kind of talk about those. The other thing we can do is we can always set up a document that's a kind of a group document that anybody can post to, or we can create dialogues some other ways. So there are some other ways that we can kind of do that, creating dialogues between when we're watching videos and that. So those are some of the different tools that we're going to use, okay? And it's very nice that we have those tools available to us now via technology. All right, so you got your notebook ready, you got your notepad ready. Let's go ahead and we're going to jump into the world of physics. Now, first of all, physics is developed out of this whole sense of there was a lot of things happening in the environment around us, and we were very curious people, okay? So we go back to the origins of mankind and we say, well, we're curious. We see the stars, we see the moon, we see the sun, we see grass growing, we see all of this different kinds of stuff around us, and we started to wonder, how did everything become? And so what developed then is this whole process of thinking about nature called natural philosophy. So it goes back to like kind of our ancient Greek people. And some of our ancient Greek philosophers like Aristotle and Democritus and those guys, they sat around and they thought about some of this. They didn't have the technology to test any of their thoughts, so that's why it was really just a philosophy. It was a belief or a theory in what we see around us. And so you look at probably one of the biggest ones was the debate between, what happens if you take a rock and you cut the rock in half and you cut that piece in half and you cut that piece in half. What happens, okay? Now, again, there was two trains of thought that went into this, and we had Aristotle who said that there's going to be an infinite number of cuts that you can make, so you can keep going on and on and on and on and on, and eventually we'll just keep cutting it in half. So that's the whole concept of going out to infinity. Where Democritus said, well, there's the other way that we could actually get to a point to where maybe there's going to be this one piece that's uncuttable, and then they deem that uncuttable piece to be called an atmos, which developed into the atomic theory. Okay, so Dalton actually took his atomic theory based on some of the philosophy that happened from the Greeks. All right, so we're trying to explain what's going on. That's the root core of what physics is. Physics likes to do that kind of stuff, is study everything around us, the world around us. And we look at it in terms of the matter that we see and the energy that's involved. So we're looking at matter and energy. Really blends well with some of our other disciplines, something like chemistry, which studies that kind of matter and the changes of matter. We're also looking at it in terms of that same similar thing. There's a very fine line between what's a chemist and what's a physicist at times when you start to look at how we study matter, how we study the motion of particles, how we look at that kind of stuff. I did actually have a nice little chance this summer to kind of do some studying or research at Augsburg, where I looked at a biology tie-in to physics. And you think, well, physics, I just want to do biology stuff. Why would I ever want to do this? Well, one of the things that we were doing was we were studying Daphnia, which are actually these little water fleas, and you looked at how they moved, and then you change either induce a drug into their environment, or you induce drugs into them, or you basically are splicing their genes. So you're actually messing with their genetic makeup. And when you're doing those types of things, you want to see how it impacts their motion or things of that nature. And so that was one of the research projects that I had a chance to work on. And then we equated that into something that we can do in the high school setting. And we're going to do that this year, is we're going to play with these little hex bugs. And the hex bugs then will be our test subjects, and we'll induce various drugging states to them to see how they interact, or how their behavior changes as we induce different things into their lives. Okay, so that's kind of a tie into it. We can tie biology in the sense of studying muscles and an arm. The way that the arm connects is nothing more than a lever. We can look into earth science, and we look at earthquakes and hurricanes that are coming through, and it's nothing more than looking at pressure changes and seeing how those things interact. And again, they all relate back to things that we can study in physics. A lot of our engineering fields, if you are planning on going into an engineering field, you will be actually taking some physics classes along the way, and so you'll see how those different physics fields, or I should say how physics ties into those different engineering fields. So we do look at technology a lot, and what happens all the time in science is that as we develop better technologies, a lot of our thoughts on what we believe to be true change a little bit. And so things are changing all the time in science. We're looking at the small particles that we're finding, and we're finding that we're discovering new interactions between them and how they behave. So there's a lot of different things can change as we change our technology. So now we go back into our thinking in science. So how do we think in science? And that's pretty much our scientific method. Now, this is kind of a recap of what you've probably learned in every science class that you've ever taken. And in fact, this entire first topic set is nothing more than kind of review topics of some basic science skills. So we're not touching into super great physics yet. That'll happen in topic set 2. But we are touching into the nature of science itself. And so when we look at scientific thinking, or the scientific method, that's the way we kind of think, there's kind of a little logical process that goes along with this. And it starts here where we look at observing. So maybe we have some kind of a problem that we want to look at. And this might even be one of those points where I'd say, if you really want to do this, you can pause the video right now, go get a candle and pull a candle out and just start to look at it. Okay, and you can make some observations based on that candle. Okay, and now maybe you've come back from looking at that candle, and you'll notice that in some fine details that there's differences between, say, the flame colors at various points within that flame. And you can maybe then study to the point to where we start to collect data. So maybe we start sticking a thermocouple into that flame, and we can see that the temperature of the flame changes as the color of the flame changes. So there's definitely a difference between, or I should say a relationship between color of flame and temperature of flame. So those are some things that we like to study. We then start to look at all that data that we collect, and we start to analyze it, and we start to then develop kind of a hypothesis. Now, in a lower level science class, the definition of a hypothesis was like an educated guess. But really what a hypothesis is we've collected data, we have a good idea of what's going on, and we kind of want to see if this is true. Okay, and so then we develop a test, and that's kind of a key thing to a hypothesis, is that the hypothesis should be testable. There must be a way that you can see if it's kind of going right or going wrong, so that you can kind of tweak it on the back end after we loop through. So again, we have our hypothesis, we know it's testable, we develop an experiment to go around that hypothesis, and then we're ending up collecting data. So you can see we're back at the point to where we go from an experiment back to collecting some more data. And then we step back through this again. So again, you're stepping back through this whole process again and again and again. And that's kind of the way we like to think in science, is we're never ending up at the very end until we actually, well, there is no end to some of our theories. And that's the whole difference between like a scientific theory and a scientific law. A scientific theory is nothing more than a hypothesis that's been tested so much that it trends that way, and it seems to be true, but we have to do, it's still open-ended and open for debate until we finally get to, it will always be open for debate. When we look at this, we also like to, talk about how we analyze data. And so when we analyze data, we start to look at it in terms of graphing. That's, our favorite way to analyze data is we like to generate graphs. We, in particular, really like to look at graphs that are going to be linear in nature. And so you can see I've collected some data here, and the data is based off of two variables. One variable, the square feet, is kind of our independent variable. It's the variable that we don't have any control over. And then you have the home price, which is the dependent variable, and so that's the variable that depends upon what the independent variable does. So we build houses, we build them based on square footage, and then we can price them based on that. And you can see that what happens here is we get a trend that looks like it's going to be kind of linear. Okay, and so that linear trend is something that we like to look at in terms of developing a model that will tell us more about what we're studying. Okay, when we see the linear ones, we know it's a direct relationship. If it doesn't come out to be linear, that means it's an indirect relationship. And really, when I talk about direct and indirect relationships, I talk about my thumb checks. So if the independent variable goes up, the dependent variable goes up as well. That's a direct relationship. If the independent variable goes up and the dependent variable goes down, that's an indirect relationship. And indirect relationships usually look something like this, where you're seeing them more on a decline, or I should say like an exponential growth or a decay type of model. Now, why do we like linear relationships so well? Well, because it ties back into some easy modeling for us. And our favorite mathematical relationship to use is this one from algebra class, okay? And the reason why we like to look at this is because of this thing called the m, which is the slope. And the slope is really nothing more than the rate of change, okay? And the reason why we talk about this is because it tells us a lot about how something is behaving. It gives us kind of some motion to that variable, so to speak. So it gives us some description about what's going on between those two variables. When we do calculate a slope, we like to calculate a slope just like we would in a math class. So it's the rise over the run, or the change in y over the change in x, okay, or y2 minus y1 over x2 minus x1. And you can look at this in terms of some points. So in other words, if I go up here and I take a point and I say that this point right here seems to be on my line, and I take another point that's right here and I put that one on my line, I can find the slope between these 2 points. So maybe this is 3,000 square feet versus 30 dollars. Oops. And then we look at this point right here, which is 1,000 square feet and maybe $500,000. So you can develop the slope based on those two numbers. In fact, that's kind of a good practice, and you should do that at the end of the video today, is actually calculate the slope based on those two values. Don't forget the units, okay? Don't forget the units for this one. And this is about the end of the video, so that's 15 minutes, and we will talk to you again tomorrow and take your questions then. Happy physics.